But we did do multiplication of rational expressions, and we need to do division still. Okay? What we have to do is our first step for division is we change to a multiplication problem. And a lot of you learned KCF, right? You keep the first one, change it to multiplication, and then you flip the second term. Then the rest of the steps are exactly the same. Then our steps are exactly the same as multiplication. We factor completely. We multiply straight across. Simplify if we can. And remember, we don't have to do FOIL or the box. We just leave it all as factored, in factored form. Okay, so for example 6, now we have a division problem. So our step 1 was to change it to multiplication, and then we're going to factor it all out. So the first thing we have to do, we need to change this guy to multiplication. So I'm going to rewrite it as x minus 1 over x plus 4. That's the keep it part. We keep this first one the same. Change it. We change the division to multiplication. And flip it, which means we take this second term and we flip it the other way. So it's going to be x plus 4 over x plus 3. When I flip a fraction, what is that called?
KFC.
KFC. What? No, no, no. If I flip the fraction, I heard somebody say it, the reciprocal. So this is the reciprocal of this guy, right? Reciprocal. If I give you 2/3, what's the reciprocal of 2/3? 3 over 2. We flip it, right? Okay, so now we have a multiplication problem, which is something that we already know how to do. When I'm multiplying fractions, does it matter if I have a common denominator? No. I just multiply straight across. So let's just multiply these guys straight across. That's going to be x minus 1 times x plus 4 all over x plus 4 times x plus 3. I didn't FOIL or use box. I just rewrote them as multiplying the two binomials. Okay, do you see anything that we can cancel? Very good. X plus 4 and x plus 4. So what would my answer be? Oh, you guys are so awesome. X minus 1 over x plus 3. So division problems are exactly the same as multiplication after we flip it. Okay, there's just that one extra step in the beginning. Okay, any questions on example 6? You guys okay with it? Let's look at example 7 then. Okay, so example 7, we have at y minus 4 over 10 divided by 4 minus y over 5. So first thing I need to do is rewrite this as multiplication. How do I do that?
Flip it.
I keep it, change it, and I flip the last one, right? So that becomes 5 over 4 minus y. Now this is just a multiplication problem, so I can multiply straight across. Now the thing that we like to remember is we always put the number by itself in front, right? So this is going to be the same as 5 times y minus 4 all over 10 times 4 minus y. Okay, now we need to do some canceling. Do you guys see anything that we can cancel? Y minus 4 and 4 minus y. Are those exactly the same?
No.
No, they're not. Because one is y minus 4 and the other is 4 minus y. Does anybody remember how I get them to look the same? Ashley? I divide by, I factor out a -1. So let's rewrite this. Do you guys want to do it to the numerator or the denominator? It doesn't matter. So which one? Denominator. Okay, so the numerator is going to stay the same. If I factor out a negative 1, that's going to make this positive 10 and negative 10, right? Times. And then when I factor out the negative 1, what happens to these guys?
Negative 4 and positive y.
Negative 4, positive y. So is everybody okay if I rewrite it as y minus 4? Y is positive and 4 is negative? Are you guys okay with that? Okay. Now do you see some things that can cancel? Yeah. Y minus 4 and y minus 4. So what's left over?
5 over negative 10.
5 over negative 10.
Could you make that negative 1/2?
I could make that negative 1/2. This is not a simplified answer. So we can reduce this to negative 1/2. Very good. Example 8. Okay. X squared plus 6x plus 8 all over x squared plus x minus 2 divided by x plus 4 over 2x plus 4. What's my first step to a division problem? KCF. So we keep it. Change it. And flip it. Okay, before I multiply these guys across, what do I have to do to each of them? Factor. So let's factor them. I'm going to look at this first term, and I'm going to look at the numerator. Can I factor that? Diamond method. Let's use the diamond method. I need two numbers that multiply to positive 8 and add up to positive 6. Jared? 4 and 2. So we're going to factor that first guy to x plus 4 times x plus 2 over, does this bottom guy factor? What method am I going to use there? Also diamond. So that's negative 2 and positive 1. So what two numbers multiply to negative 2 and add up to positive 1? Negative 1 and positive 2. So that's going to be x minus 1 times x plus 2 times, can I factor the second guy? Very good. I have a GCF in the numerator. What is it? A 2. So if I factor out a 2, x plus 2. And can I factor that denominator? No. Oh, I'm sorry. So we're just going to leave it as x plus 4. But you know what? I'm going to put it in parentheses just to keep it together. Okay? So now I get to multiply them straight across. So all I'm going to do is rewrite it, but I'm going to keep all those binomials together, right? So this is the same as 2 times x plus 4. We always put the number by itself in front. That's why I put it in front. Okay? So 2 times x plus 4 times x plus 2 times another x plus 2, right? All over x minus 1, x plus 2, and x plus 4. Are you tired yet?
No. Yeah. Just remember.
Just shut up, just say you're tired.
Now can we do the x plus 4?
Now we can cancel. What do you guys see that can cancel? X plus 4 and x plus 4. X plus 2 and x plus 2. What about this x plus 2? No, we can't cancel that one. Because there's not one to cancel with it on the bottom. We have 2 on top, but only 1 on bottom. So we can only cancel one of them. Okay, so what's left in the numerator? 2 times x plus 2 all over x minus 1. And that's your answer. It's a lot of stuff to keep track of, but do you guys understand why I want you to show every single step? That way you won't lose anything. Okay, it's very easy in this stuff to lose a factor or lose a number. Okay, so make sure that you write it all step by step out. Okay? You don't have to write this down, but I do want to look at it. All I want to do for this one is rewrite it for multiplication, but we're not going to do it. Okay? So for example 9, I have 3x plus 9 over x divided by x plus 3. Can I make x plus 3 a fraction? Yes. What do I put it over? Over a 1. So let's rewrite this in multiplication. I keep it, change it, and I flip this one, so what would it become? 1 over x plus 3. And then we do the exact same thing. Okay?